I hope there's someone left in this channel. I haven't posted a video in years. Well, today is your lucky day. We've got a overclocking guide. I want to make your PCs faster. We've got Intel's 10th gen CPUs on the bench here. I've had a little bit of experience, so why not just do an overclocking guide? So let's get stuck into it. So I'm going to, the first port of call is getting to BIOS. So essentially by hitting the delete key as you're booting, it will allow you to get into the BIOS, at least on gigabyte boards. I like to optimize default settings, save and exit, and come back into the BIOS so that I know I have a clear CMOS. Now, I am on a special BIOS. This BIOS I will use for extreme overclocking. I can't be bothered changing it, but it's not going to matter too much for you guys. It will be a pretty straightforward thing. It should operate in this instance very similarly to a regular BIOS. So what I am going to do is show you how you overclock this CPU in BIOS and then save that overclock essentially and go to Windows and do some tests and whatnot. So okay, so let's do that. So what Gigabyte's done, I like this. They've changed a few settings. They've got a new favorites menu, so you can essentially change some of the key settings that are required for overclocking. So let's change the CPU core ratio. So we'll do an easy 5 GHz overclock. All of these chips can do that. We'll do cache at about 45. Again, we will, if you've got any half decent memory, it'll probably have an XMP profile. Basically just select profile 1. It will be extremely rare that the memory is not stable, but if you are or do become unstable and you have potentially issues, I do advise that you maybe just go with default settings on the memory just to double check that that's the case. And you may have to manually get the timings going, but 90% of chance most kits these days should be able to get it to run. It is the Intel platform after all. I do like to control my load line as well, so I have found in my previous videos, and you can see my old videos, that turbo load line calibration on Gigabyte boards operates really well, and I would suggest you do that. Now for this particular CPU with 5 GHz, hard to really, every chip will be different. This is a silicone lottery, so maybe you can start with maybe 1.2 or 1.25. Just do 1.25 just to be safe, but this might be overvolting your CPU, and I've found that some chips will do it for less than 1.2, some will do it for more than 1.2, but pretty much every chip that I've tested has done 5 GHz. Now the other thing that I like to do, and we'll go to advanced menus here, advanced CPU settings, I like to turn off all the EISD and all the turbo functions so that there is no fluctuation in my frequency. I want my frequency to be fixed, right? So it's speed shift as well. Yep, so we're gonna disable that. I am pretty sure we've got everything covered. So 5 GHz, did we say 1.25? What the heck, let's do 1.2. This should be okay as well. So now when you do your first load of testing and changes, I would suggest to then save this. So what you do is you press F3 on the keyboard. It'll take you to a menu. As you can see, I've already been doing a few tests. So let's select profile 3, YouTube. There we go, YouTube, and hit F10, save and exit. Let's go to Windows and test for stability. Okay, so we are in Windows. How do we know that we've overclocked and we are doing what we set in BIOS? Well, go to download, I should say, CPU Z. It's essentially an application that will show your system settings, and it'll tell you exactly what you're running on. If this is showing like 4.9 or fluctuating clocks and whatnot, it means that your BIOS probably failed and set these settings to default. But I'd be very surprised if you guys weren't able to reach, you know, this with such a simple step. There's not a lot of, you know, there aren't a lot of things that you've changed here that would have potentially gotten your system to crash or be unstable, unless it's memory, like I said before. So I'm on a gigabyte Z490 Vision D. As I said, I'm using an extreme BIOS, but your BIOSes will probably read a D1 or, you know, have a D letter in front. Now my XMP profile has set this memory now to 1400 or 2800. And it's 8 gig kit. It's a Corsair kit, very simple, something I've had on the bench. Alright, so what I normally like to do first, I would just start a CPZ. I'll just move it here, and I will just select 32M and let this run. CPZ and SuperPi are always my first go-to when I'm overclocking a new system. So I will just let this run, and once this completes, I'll know that my memory is reasonably stable. It's not 100% stable yet, but I know it's reasonably stable, and I'll show you the next step. So let's finish this. Okay, that's done. So now we know the memory is pretty stable. So let's do a round of XTU. Intel XTU is a really handy utility. You can benchmark, you can stress memory, you can stress CPU. It's a good all-round application for you to have a good idea of how well your system is going to perform and if it's stable enough. It also gives you performance indications. So I'm going to specifically use the benchmarking tool from there, and I'm leaving this open so you can see that, but also it actually shows you everything from, you know, your system temperature. It's idling at 24. Actually my lab temp is about 20 degrees or so, so actually really, you know, nice idle temp. Like I said, we've overclocked it, we've got, you know, a decent amount of volts, so let's run XTU. Alright, so XTU is done. The temperature idled between about 30 and 60 degrees. I mean, 60 degrees under load with XTU at 5 gigahertz overclocked. You know, people were talking about how hot it runs and it's going to be an oven emitter. Well, I don't know where that rumor started, but it doesn't seem to bear much fruit in my opinion. So we've got a score, I think around stock should be around 4K mark. So we've increased that score obviously, so we are going to be much more efficient. And as you can see, the speed has essentially stayed at 5 gigahertz. So the other thing that we could potentially do here is, if you want to, let's do some crazy high temp load with small FFTs. I mean, this is going to probably hit 80s, I would imagine, but let's have a look. Just testing. This is the worst case scenario. You're never really going to see this in real life, but anyway, let's just go for some crazy load and see what happens. Monitoring. And normally this is also going to cut out if the thing isn't stable. This will cut out very fast. Anyway, so we are at about 75 degrees Celsius under load, overclocked, 5 gigahertz, all cores on a 10 core 20 thread CPU. I think that's pretty solid. I'm not going to spend a great deal of time here. I want to move on to other things, but if you want, you can continue using a test like this for an extended amount of time, say an hour or longer. That will give you a good indication of your system stability. I would also suggest maybe looking at some of these AVX based tests and maybe just set it for like an hour or whatever, and you can essentially just start this test and it'll run itself for an hour and then it'll stop once the timer is out. Obviously it'll crash if it's unstable, so but anyway, this will give you a better indication of your reasonable load temp on say gaming or CPU intensive tasks, but not completely go crazy overboard where it's stressing your VR end and CPU to the absolute max, which, like I said, is fairly rare on most people's workloads. But as you can see, it's sort of running around that 50 mark. So if you're playing CSGO, for example, or PUBG or whatnot, you're probably going to be seeing about 50-degree load roughly in the game, similar to this AVX2 test. We are going for 5.2, 1.3 volts, pretty crazy for a high core count chips. Let's see if we can make this stable in BIOS. Alright, we are in Windows. Let's go for the lie detector test. We're going to open up CPU Z. Make sure we're at 5.1. Sorry, 5.2 I mean. So all cores 5.2 gigahertz. Let's open a XDU and let's see if we're able to stabilize XDU at 1.3 volts. CPU Z, not the most accurate benchmark. I have done testing on different applications and how they measure voltage. The best way is just to physically measure it, but on gigabyte boards, if you're using turbo load line calibration and you set a specific voltage, you will generally see that under load. Okay, so let's see if we can pass XDU at 5.2 gigahertz, 1.3 volts. Alright, so 5.2 gigahertz, 1.3 volts, 4266, we are getting some huge scores now. The maximum load temperature that we saw was 72 degrees as well. It's running pretty good. It's not running hot like the internet meme culture is making it out to be, at least not in my situation. Now you can also do separate stress tests. AVX is probably one of the strongest. I would probably suggest to run 1 or 2 hours of this particular test. Let it do its thing. This will be roughly the load of playing CSGO or PUBG or something like that. So you'll probably be, seeing, I don't know, what is that, 56. So let's say probably hitting up to like 60 degrees or something load on reasonably CPU intensive tasks like that. Obviously, if you want some extreme load, you could load up some Prime 95 or just run a whole bunch of different tests, but you're never really going to truly see that style or type of load on a setup. But yeah, go for it. If you have some mission critical systems and applications and stuff, run a long test. Make sure it's going to be stable. I like to test with CPU-Z and SuperPi, and then after that generally XDU, and then probably a little bit of this longer stress test from XDU or potentially Prime 95. Whatever floats your boat. Alright, so let's recap. So, very good chips. I've tested about 5 or 6 chips. Very quick tests, nothing too crazy. 5 gigahertz easy on all of them. Some were benching 5.2 and 5.3 with a Corsair AIO, so that's good enough. That's an indication for me on what to expect from a regular cooling. So my next test will be extreme overclocking. So I'm going to use a little bit of liquid nitrogen soon, get a feel for what it's like to run 6.5 plus multi-threaded. And I know some of the guys are going to be showing world records overnight at 7 gigahertz and much higher. So very good chips, easy to overclock. Literally only 2 or 3 settings here or there. So the core thing is, you know, core frequency, case frequency. Now you can, I haven't shown you any more, you know, detailed guide, but you can increase that again. CPU voltage, load line calibration, and XMP profile. And of course, power settings. So you want to make sure that there's no core frequency fluctuation and power savings modes and stuff like that. Like when I'm using my PC, my current PC is an 8700K running at 5.2 gigahertz. 5.2? Yeah, 5.2 gigahertz. And it's running flat 5.2 gigahertz. I don't need it to save a little bit of power. I don't use it 24/7. So I turn off my PC when it's not running. I turn it on when I'm gaming, when I'm doing whatever, and then it's off again. That's how I use my PC. But, you know, by all means, you could just leave it at default if it's just for your regular web browsing and whatnot. But, you know, if you need it for something, you know, substantial, or you're gaming, or you're doing some editing, overclocking, whatever that may be, overclock it. Run to 5 gigahertz, 5.1, 5.2. It's going to be awesome. All right, goodbye, guys, and thanks for watching. Cheers.